Hello everyone, how are you all? Welcome back to the channel again. I hope all are you good and learn something new with day by day. Today we have a phone. It's a Samsung phone, right? Right now it's in a dead condition, right? Also, there will be a work on this CPU side, a totally work, right? Someone reball this CPU and it's in a dead condition, right? So we diagnose this phone and let me see we repair this phone or not, right? So first of all, just a second, connect the flex again, right? Now in top of the corner in right side there is a multimeter and the USB ampere charger meter, right? Now we connect a charger first and let me see anything remaining. Now I'm connecting the charger. Now it's taking 400 milliamp approximately. That means it's taking charge but not the complete charge completely, right? So just a second, can I press this, anything changes? No. When I remove the battery, it's still no, it's not taking charge. Now when we connect the battery, now we connect the battery and again connecting a charge. Now it's take 480 right milliamp. Not so it's not taking charge anything, right? Now we diagnose with the multimeter, right? Anything short or CPU revolving, any problem CPU related, because someone already work on this portion. I'm already told you, right? Now let me remove this battery and first we measure on a battery on a diode mode, right? So multimeter on a diode mode. Just a second. So multimeter on a diode mode and that probe on a ground side, right? No, this side 500, right? Now in a forward bias, maybe it's not connected right here. So in a battery connector there is a no short, right? And now we disconnect the motherboard and remove the cameras for latest next working. Right? So this is a charging IC and here is the graphic IC and light section, right? And this is the CPU and MMC. Now we check one by one. So let's start with the VPH. We measure the VPH first. Anything VPH in a role play. So it's a 300, 343 on a forward bias. Now VPH is also correct. That means according to the multimeter there is a no short, right? Now we look at the voltage. Is the VPH is available? Hang on. Now we connect a charger. Now charger is connected, and we measure here the voltage. Multimeter on voltage mode, right? Now on VPH, and the VPH is available 3.6 voltage. Clear? Now under this shield, there is a power IC. So we remove this shield and see the power IC, buck readings, and near about any secondary line short or not. After that, we work on diagnosis step by step. So let's remove the shield, right? Take aside this frame and fix this motherboard on a motherboard holder. Now we apply a little bit flux here on the border side of this shield, right? Also, right, all over the borders, right? Now we use this PPD or 138 and apply all over the borders, right? So temperature, the company temperature will be melt or 217 to 138, right across all over the shield, all areas, all the borders. Right now a little heat on a 250, and with the help of the iron mix this solder 138 to all over the border area of the shield. So the company temperature will be converted to low temperature, so shield will be removed easily. Now we use scraper, right? Just cut slowly the all over the border, cut it the border area. So what will happen, the 138 ppd also properly mixed with the company ppd, so temperature cool down, right? So in a 300 ppd, I mean to say in a 300 heat, this shield will be removed easily. Take your time, slowly, right? Just remove the shield, all the area, cut it. So remove shield. Now slowly take aside and this shield out, right? Now let's under the microscope. Now this is the power IC. All around there is a buck inductor, the big one, and the buck inductor and the power IC there is a VPH capacitors. Now after the cool down the motherboard, we check the values in a diode mode. Now multimeter on diode mode, right? Now we measure the diode value, right? First all of the bucks. Now one by one. Now this one 155, 157, 160, it's okay. Now it's 81, 82, 83, it's okay. Now this one is 1313. Now it's look like a short. It's also beep in your multimeter, but it's a low resistance line, so it will be okay. So it's okay. So don't confuse, it's okay. Now this one is a 284. This is also okay. Now the diode value is also okay. Now the caps around the power IC randomly, any short on a secondary line, all okay, looking all okay. Okay, okay, this side ground and this one okay. So it's look like there is a no short on a secondary. Now we connect this motherboard to the frame and see the voltages on the buck lines, right? I mean measure the voltages with the multimeter on the buck. Now multimeter on a voltage mode, right? Now we connect the charger insert, and let me see, just a second. Let's say red prop. So 3.5. Now VPH is available, right? Let me check again. Now VPH is there, 3.5 voltage, right? Without battery, only connect charger. Now we check the buck lines. This on this buck there is a no voltage. Now in this there is no voltage, no voltage, now no voltage. So in this buck lines there are no voltage, no voltage, any one off, because someone work on CPU. Maybe this is the reason. Maybe some issue with the CPU and the MMC. Maybe that's why this buck does not generate. There are less chance, so power IC does not produce the buck, right? So we remove the CPU first, and after check the buck lines after removing the CPU without power, because someone work on a CPU. That's why this is the reason I am removing the CPU first, right? Let's under the microscope. So this is a Samsung based phone and the Samsung CPU. Look at this, there is all around the flux, right? So someone work on it, maybe any reason CPU does not respond, right? So we disconnect, we remove the CPU after we check it. Now just the little flux. Okay, there is no glue here. When you use the scraper around the corners, there is no glue, right? Now little heat, and if there is under a flux, if the flux outside, that means someone work on it, confirm. 100% is someone work on it, but for the confirmation for the new viewers, right? Now look at here, when we use a scraper on the boundary line, there is a glue, but in this phone there is no glue. Someone already cut it, right? Now in this area, let's see, now the scraper easily move from one side to other. Now little heat around the CPU. Do not stuck any point, your hand rotating all the time. Just do not stuck any point of the CPU, otherwise your CPU does not work. Now look at this CPU, the flux is little outside, that means someone work on it. Let's remove the CPU also. A little heat on 320 and the scraper insert, because now heat on 350. Now scraper insert easily, because someone already work on it. Now easy one, the CPU remove, the CPU revolt. Look at, right? Now I will show you. Now look at this, there is a clearly some one rebolt, and some bolts on does not connect it. I will show you. It's look like does not connect it. Just clear my view. Now on the other side there is some bolt does not connect. I will show you. I will show you how, why I'm saying this. Now look at this. The other bolts and I will show you these bolts, right? The difference between. Now look at the other bolts and just a second, clear this thing. Now look at this. These all bolts had solder, right? But look at this. There is a my blade on it. Now look at this. These blade bolts does not had any solder. That means there is no connected. A CPU bolt does not connect. Our scraper on a first side, but these are does not connect. It's look like also the someone a one there are 2 or 3 bolts had carbon. Now look at this here. There are also you look like, but we insert the scraper, that's why here, but on that side there is no scraper. So maybe this is also a reason, right? The CPU does not install properly and does not work your phone. Right now we remove the MMC also, because sometime if you remove the CPU and does not work on the MMC, your phone does not work. Maybe a dry issue, a solder dry issue. So it's better to work on both IC. Now little heat on a 340 and scraper. Now we remove this a little scraper insert, right? So air easily pass under the IC, right? And rotating all side, right? That means this is little tough. That means this is not. Now look at here. After the MMC, no one work on this IC glued clearly. So this IC does not work. Maybe this is also the reason your phone does not turn on, right? And look at this, all the glue, right? So that's why it's little tough compared to the CPU easily outside removed because of the CPU someone already work on it, but the MMC, right, nobody work. Maybe MMC try, this is also a reason, so it does not work. Now let me little flux and the solder apply all over all the pads, right? So temperature melt or cleaning purpose, right? Now same with the MMC. Little flux here, all balls, right? Now on MMC side, this is also a temperature low from high to low. So when we place the IC, it's connect properly. There is no temperature difference. IC and the motherboard are similar temperature. Now we clean up this with the wick, just little. Do not use pressure on the wick, right? Slowly with the flux, right? Do not apply pressure on it. If you apply pressure, the motherboard UV, right? I mean to say the pads connecting each other. If you apply pressure here, just simply with the light hand apply the solder wick to cleaning purpose gently. Now same with the MMC, right? Just apply simply one or two component misplace, I mean to say, let's after we check this after the cleaning which component. Now we cleaning with the thinner, just brush it properly so all glue will be clear. One or two three time, right, properly. Now it's look like clear. Now you will see some balls has missing, right? Also the glue, no, the person does not even remove the glue, right? Little epoxy, yeah, this component is also. From here there is a resistance, right, misplaced, so we cover it again. Now I will show you in a Borneo these pads. I know these are NC pads, but for the new viewers who does not know about these pads, let me show them. These are NC, right? These are NC pads, right? So now if you want to confirm the NC pads and the value pads, so if you apply a thinner, right, you will see if there is a track goes from the missing ball, that means there is important. Also if when you scratch with the blade, you will see a little dot, a silver dot on the internally side, that means this is the important part. But if you see nothing, only just glue, that means there is NC pads. Mostly NC pads remove easily, right? So let me confirm it. Yeah, look at this, there is a blue lines, blue dots, they all are the NC, right? So this is a common when you remove, right, some pads, NC pads, remove it. Also someone work on a CPU. Now look at this resistance and look in front of 1 2 3 1 2 and 3 4. Now look at this component 1 2 3 and this line, look at this, these are all are NC. Now this is the ball, but there is a carbon, right? This ball is miss and this miss, this miss, this. And now when you look at this properly with the zoom, I will apply the thinner, let's say a thinner, but there is a no, these all are NC pads, right? For the confirmation, I will show you the Borneo, I will show you confirm again. Now look at this, these all are the NC pads, we did not, right, these are not important, right, as like a value and ground pads. Right, 1 2 3 1 2 3 4 1 2 3 4. So on a motherboard, right here, this one 1 2 3 4 NC, and just clear it. And the next 1 2, this one is also had a ball, but there is a carbon one, right here, this is also all NC balls. Now we place the resistance back where the resistance, you will see now resistance. Now let's see the resistance value, right? What was the value of the resistance for multimeter on a resistance mode, right? Now we check this resistance value. It's 2223 ohm, right? So this is the second side of the resistance, right? Now again it's a 23 ohm, right? So this side of this resistance place, right, on this side there is a 10k resistance. So we found a 10k resistance from another motherboard and we place it here. So this resistance will be on the other side. Place it. So let's move it, place it. Just slowly heat on 0, air on 0 and heat on 300, 310. Now we fix this resistance. Now we found a 10k resistance, right, on the other side, this side, right? This line had a 10k resistance. I'm already looking in the schematics, right? Now I found a 10k resistance. Now we install this here. After we measure this, a little flux on this. Let's connect this with the solder first with the iron, one corner. And apply little flux and heat up 300, air on 0. Do not use high air, so it's fly. So now it's fix it. Now after the cool down we measure this, right? I'll clear the other stuffs. Now let's check the resistance measurement once again. Right, now this one, this is a 9.9 or around 10k, right? So now let's clear the CPU. Now let's pack it and check the buck voltages, right? After the CPU, the buck line produced by the power IC or not, right? Just first of all temperature down the motherboard, right? If you connect directly in high temperature, there is a shorting chances increase. So now if this time if the buck does not generate, that means our power IC also does not work. Let's connect the charger. Just a second. Let's connect it, right? Now multimeter on a voltage mode. Right, now we measure VPH first. Just a second. Now connectivity. Just a second. Multimeter props just loose. Now we check first. Now the VPH is available, right? Clear. Now the check buck lines. Now look at here, the buck voltage 0.7 volt. Now next 1.3, right? Clear. Now next 0.7. Now next 0.7. Now that means 1.3. That means the buck voltages generate, right? There is a no CPU, right? That means power IC generate the voltages. Look at say the power IC CPU and the MMC does not installed. So maybe a CPU chances, CPU or MMC reason, right? Now we clean the CPU and the MMC, right? After we fix it, and I will show you each and every step. Now clear this with the thinner and the brush, the motherboard. Now we clean the CPU, fix into a holder first. Now let's take a holder. Now we clean this CPU with the thinner and the brush. Now look at this, some tracks look like mix, I mean disconnecting each other. Just we apply heat and let's separate it. Look at this, now these all are separate, and now look at here, I will show you something. No, first disconnect this also, separate each and every ball. Now I will show you something. The some pads also had a carbon, I mean to say look like this. When someone revolve the CPU, it does not revolve properly, right? Look at here. Right, look like this on these pads. These board does not used. It's look like maybe CPU does not proper revolve, and we revolve the CPU again after cleaning. Now a little flux, and we use iron. So every ball had a shiny. Also the solder. With the light hands, do not apply right a pressure, otherwise CPU will be scratched. Now clean the proper CPU, right? Do not hurry, just clean it properly, each and every glue, right? 2 time, 3 time, 4 time, whatever the time it takes, be patient and clean it properly. Do not hurry if you want to the result. Right now we work on MMC. Now look like MMC does not work on it. There is a glue. So first we remove the glue. Right. So first we apply flux here, and after the solder, convert low temperature high into low with the iron. हेलो। हाँ जी। हाँ, हुआ पड़ा भाई, ले जा। कोई नहीं, कर लेंगे, ले चले जा यार। हम्म। सॉरी फॉर द डिस्टर्बेंस। No, literally. Just scratch the epoxy, I mean to say glue. Right. No one work on it, MMC. Slowly, just with the scraper, a little heat and remove the glue. Now heat on a 300. Right. This is the white glue. It's easily removed. Right. Just clear all this. Right. Do not use sharp scraper. Remember, do not use sharp scraper. Otherwise, you will scratch on the IC chip. Right. And do not apply pressure. Only with the light hands. Just right on a glue. Remove the glue. Now little flux and solder with the solder wick. Just cleaning. Right. All the balls and also the glue. Right. With the light hands. Do not apply pressure all over the IC chip. Now the temperature is 330, my soldering iron. Now we clean this with a thinner. With the cotton pad on the thinner, we clean it. Right. Now let's look like nice. Just clean it. It's clear. Right. Now scratch some balls. Oh, right. Now now there is some balls at a carbon just with the surgical plate. Right. Now on a shiny side, convert a shiny side. Right. Now we revolve the CPU and the IC, both IC. Right. One by one. Now take first CPU. Now under the microscope. Now we use a universal stencil. I will show you. Now this is a universal stencil because I forget the stencil. Right, my stencil I don't know. So we use this stencil basically. Right, universal. Now just properly. Just a second. Alignment properly, each and every ball you will see. Now always use PPD on a dry side, a little wet. Right, my PPD at that time a little wet, but if you use a dry with a little cotton pad. This is a little wet. I will try to fix, but when a phone come to repair, we will suddenly fast. I mean to say, it's in a hurry, but we will apply a dry PPT now. Just we deball this. I know my English is not good, right? But whatever. Now apply all over the stencil, all the outside. First apply heat, so you can easily deball. Otherwise, stencil will be get air and stencil will be pull up. Now the CPU will be deballed properly. Look at this. Now do not take stencil, I mean to say your tweezer out immediately. Just wait for 7 seconds and after the cool down. Now apply a little flux here. So every loose ball, right, who does not connect it properly. Now apply heat again. So every ball, I mean, right, a loose ball connected properly on a place. So while you remove the stencil, right, it's connected to the chip, not with the stencil. Now wait for some seconds, right. Now apply thinner, right, and the brush to remove the IC. Now on the main camera, now apply thinner and the brush to clear unnecessary balls because we use universal stencil, right. So clear it properly, clean it. Now let's see under the microscope. So our CPU will be revolved properly. Look at this. The all balls are looking good, right? A proper revolve. Clear. Now we use MMC. I mean to say revolve the MMC. So same method apply here, right, with the stencil, proper alignment and the PPD, right. A little heat on a 300 and air on 0, right? First all around the stencil and after from one side. Now the revolved MMC. Now one little heat again with the flux. Now the MMC is also ready. Clean it and take a stencil out. So MMC is also revolved properly. Look at it. I will make sure I will give you a proper quality, but there is some issues, right? But you can understand, right? Slowly we will fix all issues. After that we will give you a better quality videos with the better everything. Now we fix this both IC one by one. First we CPU apply little flux right on the motherboard. Do not apply flux on a one side. Apply and spread it with the finger. This is by way. Everybody had its own. Now place it CPU according to the dot. Right? Remember always dot location. Right before the IC placement. Right. Now according to these arrows, alignment properly. Now heat on 320 and air on 0. A little heat on corners first. Right. Now we apply slowly of flux. Right. After the 10 or 20 seconds. Now there is a little flux. Not the top, underside. Right? Now the flux is internally. Now let's heat up. Rotate your hand. Do not pause. I mean to say stuck on any point. Just rotate your hand. Rotate. So right now when the flux is out, that time your IC is connecting properly. That time you just click it. I mean to say just move it a little pressure or normal. So if your IC move back to the place, that means your IC is installed. Now look at this, heat up and the flux is out. Right, you will see there is a flux is out. Now we move this IC, just shake it a little, shake it right here like this. Now IC is placed back. Now that means this IC is completely right. Okay, from the all corners you can shake it. So for confirmation, if you had experienced, right? Now CPU is connecting properly. Let's cool down the motherboard. After we check the port detection, I will show you. Who are new, they do not know about that. After we connect the PC, after cool down the motherboard, right, with the data cable. So if a new port detected on a device manager, a CPU port. Basically this is a Samsung, so if a Samsung, that means Axonics CPU. If a Qualcomm, that a Qualcomm 9008 CPU port detected. If MTK, then MTK port detected, right? So if the port detected without MMC, only with the CPU and the power, that means your 90% CPU will be okay, because your PC, I mean to say your laptop, detecting it. Now we fix it after the cooldown, and we check in the PC for the confirmation to the CPU. Wait a second, I will add on a device manager in front of your screen, both screens in a similar frame. Just a second. Now in front of you there is a device manager, right? Now there is a device manager. Now connect the cable and you will see a sound, and this now there's a Axonics CPU port, right? Axonic port available. Now we remove this cable, a sound, and we will see the port is gone, not visible. Now we again connect it, right? Now the sound is on, and the new port Axonics, right? So that means CPU detect the, your laptop detect the CPU, other processor, your laptop processor detect the phone CPU. Like as a downloading purpose you use this ports, right? I hope you get my point. Now that means our power section, right, also the CPU will be okay, both are okay. Clear? Now we place it MMC after we check it whether it fix it or any other issue with the phone. Now just clear these bolts, extra solder bolts. Little flux, do not write all the solder, excess solder on the motherboard. Now we clean it. I'm told you I have I'm always try to give you a good content. I'm into taking now a little flux here, as I already told you. Spread it, do not apply a one side on the middle, and you will place a IC after you will heat, then your IC will be moved. If you spread it, it will be clearly fixing easily. Now according to the location, your dot, right, and the placement accordingly to the dots, I mean, right, and align the IC properly. Now apply heat. Now heat is in 320, air is 0. I'm using 857 DW. a little heat, a same pattern. When the flux is out, you will just little shake the IC for the confirmation, right? A little flux again. When the flux is out, a little shake, right? Now look at this, the flux is slowly now that the time fluxes look like outside, right? Now shake this IC or from the corner, right? Look like this, just a normal, right? From all sides for the confirmation, like this, right? Like this. If you use pressure, a bowl connecting internally, do not apply pressure. If IC move back, that means it's connected. Now after the cool down, we will check this motherboard, right? Now I told you, as like, I give you a good content, a good quality videos, educational videos, and it took a lot of efforts and hard work. But from your side, there is a no response. The channel is not growing, right? So please make sure support us to grow the channel. Now cool down the motherboard. I give my work. Now it's your duty, right? From my side, I'm giving a full effort for you. Now we fix this to the frame, and let's we measure the voltages first, right? If the voltage is available, stable or not, right? So again, multimeter on your top side. These case studies take a lot of efforts, I will tell you, because we taking lot of things, lot of cameras, I mean to say lot of things together. Now we're connecting a charger and we measure the voltages, the buck lines. Now we connect the charger, we measure the voltages, right? First VPH, we measure the VPH. Just now VPH is available, right? Now we check buck lines, 0.7 stable, now 1.3 stable, now 0.7 stable. Now these all our B conductors are at a voltages, I mean to say a buck lines. Now we connect a charger and let's see, let's try to on, but there is no switch, there is another external on switch. Let's connect the charger. Now it's take late charge. Now it's 1.7, 1.8. Now the logo appear. Now we let connect the power on off switch. Now let's connect the, now let's turn on. Now it's turn on. Now it's turned on completely, right? That means the fault on a CPU. Someone while repairing the CPU, it does not connect properly. Let's just sleep out. Let's press the power button again. Now it's okay. It's completely okay. I will worry. It's again dead. So it's completely okay. 1 2 3, right? So someone, it's job done. We will see you in the next video.